This video, we're going to be covering the introduction to biochemistry in any biology course. So what is biochem? So biochem is just the chemistry of life. And basically, all things are built from carbon-based molecules, water, and macromolecules. So carbon-based molecules, water, and your macromolecules, which are proteins, carbs, lipids, and nucleic acids. Okay, so why carbon? Why carbon? Carbon can form 4 covalent bonds, and because of this, it allows us to create chains and create branches and rings and 3D structures that are complex. So no other element can do it as well as carbon, which is basically why we love carbon so much. And now we can talk about the hydrocarbons. So hydrocarbons are the molecules with only C and H. So why does this matter? This is because they store lots of energy. And also, because CH and CC are high energy. These are high energy. So these are usually found in fats and lipids. Remember, more of them, more of these bonds equals more energy. More of those bonds equals more energy. You want lots of those bonds to have a lot of energy. So now we're going to talk about some of the carbon geometry. So some carbon geometry. We know that, okay, so you know that single bonds, our carbon is going to form a tetrahedral shape. And your bond angle is going to be approximately 109.5 degrees. Now, on the other hand, when you have double bonds, this is when carbon, it becomes planar. And at this stage, you have no free rotation, because double bonds, they change the shape. So when this happens, when you change shape in chemistry, that also affects function. It affects function. For example, you can think about unsaturated fats. That is changing the function. So now let's talk about some isomers. What in the world are isomers? So isomers are the same molecular formula but different structures. So it's basically the same combination of elements, but it's just in a different arrangement. So this means same atoms, different arrange, and also means different properties because of that arrangement. So you should be able to identify the following, which are going to be structural isomers. So structural isomers. So let's think about this. So you have like C. Okay, that's gonna be 5 C's, and then let's say you have H. So a structural isomer is like when you have, this is the same chemical formula, C, and then you have up here, you have a C, and then here you have an H here, and you have an H here, you have an H here, and you have a H here, you have an H here, you have an H here, you have a H here, and you have an H here, you have. Okay, so all of this, it has the same carbon backbone. Right here, you can see the carbon backbone. It's just a little bit different. Okay, now let's talk about cis trans isomers. So what in the world does this mean? So you have C, and then you have X here, and then you have H here, you have H here. So cis isomer means that the two X's on the same side. So think about like that is the line of symmetry, right? And then they're both on the same side. Now if you have something like this, you have like H, C, X. Okay, just two C's. And then X here, and then X, and then H here, right? So this is when you have cis is on the same side, and then trans is mean the two X's are on opposite sides. So remember, trans means like transport, translation, a movement, transport. So it's on the opposite side. You think it can travel to the other side, right? That's pretty simple. Here. Okay, now what about our final case? Our final case is going to be discussing enantiomers. So imagine that you have your hand right here, right? Your hand like this. And then you have a molecule like this. So you have a thing here, you have here, and that's carbon. Imagine this is a CH3, and then imagine this is an NH2, and then this is a CO2H up here, and then imagine over here you have basically the same thing, CO2H, you have an NH2, and then you have a CH2, and an H here, circle, H here. So what is the difference between these? Well, let's connect these so we can actually show. So we can see that here and then there. Now here we have this connection, and we have this, and it connects like this. There's also a C in the center. Okay, so what's the difference between these? Red, blue, and red. So the difference between these it's just like 3D reference. So this is L isomer. It means you have different POVs basically. And then this is the D isomer. It's the same molecule, but it's just from a different perspective. Now let's talk about some examples with this. You can think of ibuprofen and albuterol. These are different drugs, and they treat different conditions. So ibuprofen treats pain and also inflammation, and albuterol, it treats asthma, because they have different effective enantiomers and different ineffective enantiomers. So these cause different functions just from having a different arrangement, different structure. So let's talk about the properties of water. So properties of water. So basically the thing that makes water so powerful is because it has polarity, and then the polarity gives it properties. So this includes the idea of it being the universal solvent. So it basically can dissolve a lot of different things. Basically water can dissolve like the greatest amount of things out of all different things, and also has a very high heat capacity. What that means is that it can survive really long without changing to a different temperature, and then it also has a really high heat of vaporization. So again, it's really hard for it to turn into to evaporate compared to other things. It also has adhesion, which is sticking to other things. It has cohesion, and it also has surface tension. And also you need to know that the density of ice is going to be less than the density of liquid water. So that's why ice floats inside of your drink, and also ice floats on the pond. That's why you can go ice skating. And now let's talk about the pH and buffer systems. So pH and buffer system. Okay, so well, pH is, what is pH? It's the measure of H plus concentration. So pH is going to be equal to the negative log of the hydrogen plus concentration, and the pH plus POH is always going to sum to 14. So this, imagine this is like 7, and then this is going to be 5. And then the buffer systems, what do buffer systems do? They maintain pH. Maintain pH. So what is Le Chatelier's principle? Le Chatelier's principle is the equilibrium of a reaction will shift to counteract change in the concentration of products and reactants. So what this means is that if you alter one thing, the other thing will have a reaction, of course, and you are trying to counteract the change of it. So you're trying to balance it out, basically. So what does this mean? It means that changes in acidity results a shift in the reaction rate to get back towards equilibrium. So you can think about it like this. This is an example. We have H2CO3, and it's going to shift to HCO3 minus plus H plus. And this is going to be so it goes to the right in a response to rise in pH, and then when it goes to the left, this is going to be a response to a drop in pH, a drop in pH. H plus is a donor, making it an acid, and then here we have that our H plus is an acceptor, H plus acceptor, making it a base, and then we have a hydrogen ion. Now moving on to our next topic, we have the idea of water polarity. Well, let's move back to water polarity. Water. Yes, water here. So why is water polar? It's polar because oxygen more electronegative than hydrogen because of its location on the periodic table. So this creates partial charges. We get partial charges, and our partial charges is O is going to be closer to, this is negative, yes, and then H is going to be positive. So you can think of this is why we get hydrogen bonding, and that's where we get our special properties. So you can think of this. So we have here inside of this, we have positive S plus, and you have here, you have bonds like this, and you have here S plus, S minus. In your first ring, you have 2 bonds here, and then second ring, you have right here S minus, and then you have 2 more S minus, and then you have a plus right here. So this, you have this, you have this part, and this is going to be an S plus as well. This is going to be red, and that's why we get the hydrogen bonds. Hydrogen bonds is when you have like O, you have H, tiny little hydrogen atoms, H, those are your hydrogen bonds. This is a covalent bond. Your hydrogen bonds are going to be between the O and H. So yes.